Now, at the moment I've been seeing lots of videos on social media where people are telling other people how to adjust the flow temperatures on the boilers because it's going to save them lots of gas. Now, some of the information I've seen is alright and some of the information I've seen is absolute rubbish. So, before you go and adjust your flow temperature on your boiler, you need to watch this video. So, let's get on with it. Now, before you go and adjust these flow temperatures on your boiler, you actually need to understand what type of boiler you have. Now, since April 2005, all boilers sold in the UK have to be condensing boilers. But condensing boiler isn't a type of boiler. The types of boilers we have are Combi Boiler, System Boiler, or heat only / regular boiler. They're the same boiler, but we have given different names. So what's the difference with them? Now, this boiler I have here is a Combi Boiler. So inside here there is a plate-to-plate heat exchanger. So this boiler heats your hot water and does your central heating. But a system boiler and a regular boiler / heat only boiler just does the heating. You will require some kind of cylinder to heat your water. You call it a tank, but it's not a tank. We went to war in a tank. We actually heat water in a cylinder. And there's two types of cylinders. We've got vented and unvented, but we don't need to go down there. So before you start adjusting your flow temperatures, just make sure you know what type of boiler you've got. So now, hopefully you understand which boiler you've got. So if you've got a regular boiler or a system boiler and you are heating your water by a cylinder, that cylinder water temperature within it has to be kept above 50 degrees because of Legionella. And normally we store water in the UK between 60 and 65 degrees. Because it gives us that optimum temperature when we're running the water, and it recovers quickly so you don't run out of water. So you've got to bear that in mind. So if you've got your boiler set at 80 degrees and you've got a cylinder, then you can adjust your flow temperature to about 60 degrees on the boiler and see how you cope with actually running out of water or not when you need it. But if you have one of the most common boilers in the UK, so the most common boiler sold in the UK is the Combi Boiler, you can adjust the flow temperatures for the hot water and the heating separately. But there's some things you need to think about before you actually start going and adjusting that flow temperature. Now, first thing is the building regulations part L, which is the conservation of fuel and power, covers this. And it was updated on the 15th of June 2022. And there's now 2 volumes. And it covers new installations and replacement of boilers. So, a lot of people think the building regs only cover new installations. They did, but now replacement boilers are in there. And we're talking about low temperature heating now within the building regs part L. It's saying our maximum flow temperature on our central heating should be no more than 55 degrees and our heating systems should be designed for 55 degrees. So if you're having a boiler changed, you need now to have your house surveyed to actually see if your radiators, your pipework and your installation will actually allow for a 55 degree flow temperature. If you don't, then you might have to have your radiators and your pipework replaced for bigger pipes and bigger radiators, because the lower the flow temperature, the bigger the radiator will require to be able to heat the room to desired temperature. So again, before you start adjusting that flow temperature, we need to know whether our radiators are big enough to be able to cope with the reduced temperatures. But luckily enough for us, most plumbers and gas engineers have been oversizing radiators for years, So your radiators could actually be the right size for lowering your temperature to 55 degrees. But it could be the pipework coming in to the radiator, because if you've got 8 or 10 millimeter pipes, or the small pipes coming into your radiator, then there might not be enough water delivered to come into that radiator to give you the temperatures. So it's important that when you have your boiler serviced and checked, which you should have for every year, that when your gas engineer comes out to have a look at it, they can explain that more to you and see whether dropping this temperature is viable for you or not. Because what we need to understand is what's called the mean water temperature, or the MWT. And basically what the mean water temperature is the average temperature across your radiator. So we need to understand this so we know how it works. So the average flow temperature at the moment before this regulation changed was 75 degrees. And the difference between our flow temperature on the boiler and our return temperature has to be round about 20 degrees. So it's between 10 and 20 degrees is the best temperature for the difference between our flow and return. It's called the delta T. So if we do have a flow temperature of 75 and we do have a 20 degree difference between our flow and return temperatures, so we've got 75 plus 55 is 130. We divide it by 2, gives us our means water temperature of 65 degrees. So that's normally what radiators are set up for. So if we're reducing the flow temperature to 55, our means water temperature then will reduce to 50. But that's with a 10 degree difference, because we'll be very, very unlikely that if we're reducing our flow temperatures on a traditional system set up for 75, we're actually going to get this 20 degree difference across the boiler. Now, your mean water temperature and your delta T are also needed for when you want to size radiators. But this time the way you work it out is it's the temperature of the radiator again and the room temperature is taken off there. So if you've got a flow temperature of 70 degrees and you've got a room temperature of 20 degrees, 70 minus 20 gives you a delta T of 50, and that's how you would size your radiators here from your delta T of 50. Now there's a delta T of 60 on this radiator catalogue, and that's because your flow temperature is 80 and your room temperature is 20, and that gives you your delta T of 60. So understanding your delta T and your mean water temperature is important because the radiator sizing is so much different depending on your flow temperature. So if your flow temperature is low, technically your radiator, what is in your house, is designed for either 80 degrees or 70 degrees. It's not designed for 55 degrees, so your radiators might not be big enough. Why do we call them condensing boilers? Well, we call them condensing boilers because they take out a lot of heat out of the flue system. It's called the latent heat. So in a nutshell, what that means is our flue temperatures go lower than the dew point of the water, which is 55 degrees. So instead of it being steam coming out of your flue, it actually turns it back into water and runs through the heat exchanger and then through to drain. So that's why they're called condensing boilers. And we need to keep our return temperature lower than 55 degrees to allow the boiler to condensate, because if your return temperature comes over the 55 degrees, it won't be in condensing mode. So this is why they've brought this maximum flow temperature of 55 degrees out, is because your boiler then will always be in condensing mode when it's running on the central heating. So it doesn't really matter about our return temperature being 20 degrees difference. If we can get it 20 degrees difference, then we are using a lot of heat. But it's unlikely we will get that, and our means water temperature will go down to 50 degrees. So that's basically the science behind reducing your flow temperature on your boiler from 82, which could be the maximum, to this 55 degrees. And obviously if you can get it any lower than that and still be comfortable, you're going to save even more money when we've got these massive hikes in gas and electric prices. Now, this is how easy this one is to change your temperatures on the front. So you can see the hot water is set at 60 and the central heating is set at 82. So we've just got these plus and minus buttons on the hot water and central heating. Now when it comes to adjusting the hot water, this is trial and error at your tap. So you will be pressing up and down your temperatures, trying your tap at your kitchen sink or in your shower or in your bath. But if you can get in a bath without putting cold water in, then you've set the water to the right temperature. But obviously if you need to wash the pots in your kitchen sink, then you'll need hot water to kill the bugs. Or if you've got a dishwasher, set it up from your bath temperature. So that will take a bit of altering, but the more you can adjust this temperature down, the more money you're going to save. And when it comes to the central heating one, it's just a matter of dropping it down to 55 first. And then trying it from there. See if you can sit in your living room watching TV and feel comfortable. You might need a jumper on, but it's better and will save you money than getting it at 82 degrees and be opening windows because you're too hot. So loads of different boilers have different ways of adjusting the temperatures, so read your manufacturer's instructions on how to do that. Now, are there any other considerations we must be considering before we're lowering this flow temperature? What about pumps? Now, if we are making the radiators bigger and we're putting bigger pipework in, then the pump speed might need to be increased, or the pump could even need to be made bigger. Now, in a combi boiler, the pump is inside here. This thing here is the pump. And since 2015, all boilers sold in the UK have to have an ERP pump, or an energy rated product pump. And that means as the pressure increases in the system, then the pump slows down to save energy. So if thermostatic radiator valves start to shut down in the system, the pump will then notice the increase in the pump pressure and will reduce its speed to try and keep everything tickety-boo and this return temperature lower than the 55 degrees. So that's one consideration. Other considerations, which nobody seems to be mentioning, is your room thermostat. You should have a room thermostat to comply with the laws. So from 2005 it's been law that room stats need to be installed, and now with all the ERP directive they have to be not just smart thermostats but be able to know what the temperature inside the house is to adjust the flow temperatures on the boilers. So the room stat is incredibly important. If you're setting your flow temperature lower and you haven't got a room stat, how does the boiler know when to turn off? Because your room stat is key. Now, it used to be 21 degrees your optimum room temperature. According to Part L now, they've reduced that to 19. And if you can get it any lower than 19, then again, you're going to save more money. So it's not just adjusting your flow temperatures. The considerations are your radiators big enough? Is your pump big enough? What type of system do you actually have? Do you have a room thermostat? Have you got thermostatic radiator valves? And what temperature do we set these thermostatic radiator valves to? Now, most thermostatic radiator valves are numbered 1 to 5. 5 means it's permanently on in most radiators. So if you can set a bedroom to 2 or 3, a living room to 3 or 4, and then obviously your bathroom, because you're going to be naked, you might need it a little bit hotter, but not really that much hotter, then you can use your thermostatic radiator valves in conjunction with your room thermostat. But your room thermostat should not go in a room with a thermostatic radiator valve because they can fight against each other. That's other considerations. If you can lower your room temperature and lower your radiator temperature by your flow temperature, then you're going to save money, you're going to save energy, and you're going to save this planet with your CO2. But you need to take all these into account. Also, lowering your flow temperature is going to take a lot longer to heat your house. You've got to bear that in mind. But the lower temperature compared to the higher temperature with the longer time run, actually you will save more gas doing that than you would do setting your boiler onto maximum and running for a couple of hours, because your boiler wants to try and keep running all the time and stay in condensing mode and be able to save and use that latent flue heat. Hopefully, now you've listened to a bit of science towards it, you now understand why lowering your flow temperature is important, but you can't just rack up to your boiler and go and turn it all the way down. You can do, but it can actually put you off doing it because your house will be too cold and you can't sit in it and you'll get poorly and you'll get mold and damp, because that's not what we want in this situation. There are going to be people out there who are going to be put in this situation where, do I put food on the table or do I keep my family warm? And that should not be happening in this country in 2022. There should be no way the government will allow people to have that where feed my family or do I keep my family warm. For me, that should not be happening in this day and age. We're now not in the Victorian age now. Also, is there anything else we can do besides lowering this temperature and our room stats and our thermostatic rad valves and making our radiators bigger? Well, yeah, insulation is key. You need to get in that loft and get your loft insulated to within an inch of its life. If you've got really good insulation in your loft, put some more in, because that's where all your heat goes in your house. What about pipe insulation? So if you've got an airing cupboard with a cylinder, remember it's a cylinder, not a tank, then all the pipes coming off there need to be insulated to stop all that heat loss and wastage of heat from going to your cylinder. Now if you've got an airing cupboard and you open it up and all this heat hits you and your towels are lovely and warm, then you're wasting a lot of heat. Also, that cylinder inside there, if it hasn't got a jacket on there, or the foam, the expanding foam around that cylinder, then you need to put a jacket around it. Oh, put 2 jackets around it if you haven't got them, because you're going to lose a lot of heat through that cylinder. So as well as your loft insulation, all your pipes need insulating as well, and insulation is quite cheap from the likes of our DIY shops. So get all your pipes lagged as well. It doesn't just stop them freezing, it also stops the heat coming out there as well. Also, if you go up into your loft and you've got a feed system in there, an F&E system for your heating system, make sure that's got a lid on and it's well insulated and all the pipes are insulated, because again, as well as stopping it from freezing, you're stopping it losing heat in the cold areas in your loft. Big importance, insulation. Windows. If you've not got double glazing, well, you need double glazing because your heat goes out through your windows. Cavity wall insulation. All these things will help massively to reduce your fuel bill. But obviously they need an investment putting in, and there may be some help for things like that. So you need to look around and see if anything like that happens. Now also I've seen on the interweb people turning their power supplies off in their houses when they're going out to work to save electricity. What about your fridge freezer and your fridge? What about your food you've just bought and put it in that fridge? You turning it off, going out your house for 10 hours, coming back, are you expecting that food to be okay? Yes, go round and turn off appliances you don't need, like your TV. Even things like your router for your internet when you're not at home, turn it off. Your microwave, if it's got a light on there or it's got a clock, turn it off. Turn those things off by all means. Disconnect your kettle, don't leave phones charging when they don't need charging, but don't turn your fridge off. That's important you keep your fridge on, because you turning your fridge off and letting it go warm is going to need more energy to get it back up than it would do while it's been running for 10 hours. And also all that food's ruined inside and you could get food poisoning and stuff like that, so don't turn your fridge off. Yeah, go round, turn all your appliances off, but don't turn your fridge off. Just remember as well, guys, standing charge. You get standing charge for gas and electric, whether you use it or whether you don't use it. So they've got you that way as well. That's my look at reducing these flow temperatures. The more you can do, the small little things you can do, the more energy you're going to save, and hopefully you're going to be able to afford those increasing bills and be able to get through this winter. Get your gas appliances serviced before winter, get them checked over by your professional gas engineers, get their information off them, and get your system set up correctly, because there are other things they can do, like reducing your boiler by range rating them, reducing the gas output and stuff like that, but only a gas engineer could do that. Remember, you must be a gas engineer to open up a boiler and take the casing off. Adjusting the actual temperatures are things you can do, as you've seen, outside on the boiler. Don't go playing on the inside of the boiler or any gas appliance unless you're gas safe registered. Anyway, hope you've liked the video. Catch you on the next one, guys. Cheers.